So in this lecture, we are going to be looking at the practical activity 7.1, and it is a redox titration. When we talk about redox titration, we are talking about reduction, oxidation, reaction, right? And we are going to be using potassium permanganate against oxalic acid. Is that okay? Now, one of them is going to be the oxidizing agent, and the other one is going to be a reducing agent. Now, as time progresses, when we are done with the entire calculations, we'll be able to point out the one that is an oxidizing agent and the one that is a reducing agent. Now, it's a very simple practical, and I believe most of you also did it and got your values accurately. Potassium permanganate is purple in color, and this titration does not necessarily require the use of an indicator. I guess you guys did that. You didn't actually use any indicator to perform this practical. I don't know, you might have done something otherwise in the lab, but that is how it ought to be. And the oxalic acid was supposed to be standardized. All right, it was supposed to be standardized because the oxalic acid is a oxalic acid. Well, it depends. If oxalic acid is already a primary standard, that means the concentration is accurately known. And if the concentration is accurately known, it means you don't have to standardize it. So before it will be given to you in the laboratory, it means the accurate or the exact concentration of oxalic acid was already calculated, hence it is standardized. Now, I know all these things I'm saying to some of you is like I'm singing a poem. However, let's just go straight to what we have here. You did the practical, and I also saw that some of you were making errors here, this table. This is the right way the table is supposed to be. You have the initial X, and your initial Burette reading and final Burette reading, X and Y. Is that okay? The volume of oxalic acid remains the same, which is 5.0 ml for each of the titration you carried out. Then the volume of KMnO4 is the titer value of KMnO4. That is your final minus initial. 19.5 minus 0, this one gave us 19.5. And then 19.4 minus 0, this one gave us 19.4. And then 19.5 minus 0, this one gave us 19.5. I believe in this particular practical, you didn't actually do any rough. Hence, the three of them, they are accurate titer. Hence, you are going to use them to get your average volume of KMnO4 used. So if you have gotten this table, my dear student, the next thing you need to do now is to get the average volume of KMnO4 used. How do you get the average volume of KMnO4 used? It's a very simple thing. You are going to say average volume of KMnO4 is equals to, you add the 19.5 to 19.4 to 19.5. Depends on what you've gotten here for your particular practical. Like I usually tell you, you don't have to copy what we have here. Use your values to get your answer. Is that okay? So this will be 19.5 plus 19.5 plus 19.5, all divided by how many do we have here? 3. So when you punch that in your calculator, what are you going to have? Let's have it this way. That will give us 19.5 plus 19.5 or plus 19.4 plus 19.5, all divided by 3. That gives us 19.46 approximately. All right, 19.46 something, approximately still 19.5. 19.46 mil. So the average volume of KMnO4 used is 19.46 mil. That is what you are going to write there. Average volume of KMnO4, 19.46 mil. Is that okay, my dear student? Now the next thing is the calculation. Now they gave you this sheet in your manual, the formula. A1 M1 V1 is equals to A2 M2 V2. Each of the parameter or each of the terms there we actually define. They say A1 is equals to 2. It was given. It says the number of electrons lost per formula of oxalic acid in a balanced equation of half-cell reaction. Now, some of the questions require you to do some half-cell balancing of equation. All right, A2 is 5, the number of electron gained per formula unit of potassium permanganate in the balanced half-cell reaction. Now, my dear student, there's something that you need to know. When we come to oxidation reduction reaction, there are actually two reactions present there. We have the oxidation half reaction, and then we have the reduction half reaction. Is that okay? Now, the number of electrons lost per formula of oxalic acid in the balanced half equation is A1, which is equal to 2. That of potassium permanganate, which is the electron gain, is A2, which is equal to 5. Now, M1 and M2 are the molarity of oxalic acid and potassium permanganate solution, respectively, used in the titration, while V1 and V2 are the volumes of oxalic acid and potassium permanganate used. All these are given in your manual. Now, from here, A1, M1, V1 is equal to A2, M2, V2. If you put in the value of A1, we said A1 is 2, A2 is 5 into this equation. So it means wherever we see A1, we put 2. Wherever we see A2, we put 5. So this will give us 2M1 V1 is equals to 5M2 V2. Is that okay? I don't know which of my lights they shake. It's not supposed to be this one now. It's affecting my eyes. All right. So A2 is equals to 5. So wherever you see A2, put in 5. For oxalic acid, you have 2M1 V1. Potassium permanganate, you have 5M2 V2. Now, this is already your manual, so you don't necessarily need to write it down. Is that okay? From here, if you make M2 the surrogate of the formula, you are going to have 2M1 V1 all over 5 V2, because to make M2 surrogate of the formula, you divide both sides by what? 5 V2. So 5 V2 cancel 5 V2, everything here. And then you are going to have M2 to be equal to 2M1 V1 all over 5 V2. The molarity of oxalic acid given for this titration is 0.1 molar. Is that okay? And the molarity of, the volume of oxalic acid given is 5.0 milliliter. V2 is this calculation you did here, the average volume of KMnO4, because V2 is the volume of KMnO4 used. So the average volume of KMnO4 for this particular practical is 19.46 ml. Now, this value is subject to your own readings. Whatever readings you get them is your value. So don't go and copy 19.46 there. You will fail very well. Use your own values. Even if you get 9, if it's not 19, if it's 15 or anything you got there, just write it there. Is that okay? So that's our V2, 19.46 ml. Now, the question now is, the molarity of KMnO4. The molarity of KMnO4 can be calculated using this formula, right? The formula says M2, look at it, M2 is equals to 2M1 V1. So we have 2M1 V1 all over 5 V2. Is that okay? All over 5 V2, this formula here. M2 is the molarity of KMnO4. Look at it. M1 and M2 are the molarity of oxalic acid and potassium permanganate. Potassium permanganate is KMnO4. Is that okay? Now, my dear students, M2 will be equals to 2 times M1 is 0.1. So we have 0.1 here, times V1 is 5 ml. So, my dear students, we have 5 ml here, divided by 5 times V2 is these values you have here, 19.46. So this is 19.46. Now, my dear students, our M2 would be equals to, when you punch this in your calculator, what are you going to have? It's going to give us 2 times 0.1 times 5 divided by 5 times 19.46. which gave us approximately 0.010 molar. All right, so that is our M2, my dear students, 0.01 molar. Is that okay? 0.01 molar. Now that you've got to your 0.01 molar, I think that is everything that is expected of you there. The next question is, what process could be used to describe the conversion of heptaoxo dichromate to chromium 2 plus? What process could be used to describe the conversion from this to this? Is it oxidation? Is it reduction? First of all, we need to know the oxidation state of chromium here and the oxidation state of chromium here. Now, you have Cr2O7 2 minus. What is the oxidation state of chromium here? How do you calculate it? Now, while you were in secondary school, we were taught that the oxidation state of all ion, right, is equals to the ion, right? The oxidation state of all ion, my dear student, is equal to what? The ion. So this chromate ion here is an ion, of course. So the oxidation state will be equal to the charge on this ion, which is 2 minus. Now, how many chromium do we have here? We have 2. So we have 2Cr plus. What is the oxidation state of oxygen? Oxygen has an oxidation state of 2 minus. So we put minus 2 times 7. Everything will be equals to what? Minus 2, which is the oxidation state here. So here will give us 2Cr. Minus 2 times 7 will give us minus 14 is equals to minus 2. So 2Cr would be equals to, if this minus 14 crosses to this side, becomes minus 2 plus 14. And then 2Cr, minus 2 plus 14, my dear student, will give us what? Minus 2 plus 14 will give us 12. So divide both sides by 2. This cancel this. Cr will be plus 6. So the oxidation state of chromium here is plus 6. While the oxidation state of chromium here is 2 plus. Now, what is the best name for that process, or what best describe that process, the conversion? Of course, you can see that the oxidation state of chromium changed from Cr6 positive to what? Cr2 positive. So this is a reduction. When there is a decrease in the oxidation state, you say this is what? A reduction. So what process could be used to describe the conversion of this to this? You could write that the process that can be used to describe the conversion of what you have here to this is reduction. This is because the oxidation state of chromium was reduced from 6 plus to 2 plus. The calculation below verify these facts. Are you getting it? And then you do this particular calculation there and you are good to go. That is the explanation you should give to that. So first of all, the question is, what process could be used to describe? The process is reduction. This is because the oxidation state of chromium reduced from 6 positive to what? 2 positive. Are you getting it? And since the oxidation state reduced, then the process is a reduction process, and the calculation below could be used to verify. Are you getting it? Just put it the best way that you can actually do that for this particular one. All right. Now, I say determine which compound or ion is the oxidizing agent in the given reaction. Now, the oxidizing agent is the one that is being reduced. That means anyone that the oxidation number is being reduced is the oxidizing agent. If you look at aluminium here, oxidation number of aluminium here is 3. But oxidation number of aluminium here is what, my dear students? 0. So it means the oxidation number of aluminium reduced from 3 to 0. And if it reduced from 3 to 0, I told you that the oxidizing agent is that agent that is being reduced. So it means aluminium 3 plus is the oxidizing agent. This is the oxidizing agent. Why ion is the reducing agent. Is that okay? Because that is what you are expected to do in this particular one. Just determine Al3 plus is the oxidizing agent. So how are you going to write it? First, you are going to write that Al3 plus is the oxidizing agent. This is because Al3 plus is reduced from Al3 plus. I mean, the oxidation number of Al3 plus was reduced from 3 to 0. Hence, it is the what? Oxidizing agent, because in oxidation reduction reaction, the oxidizing agent is often the one that is being reduced. Are you getting the idea now? First premise you establish is this: oxidizing agent is the one that is reduced. So you are going to look at the equation. Anyone that is reduced is the oxidizing agent, and in this case, it is what? Aluminium. Why iron is being oxidized? Is that okay? So iron is the reducing agent. So that is that for that question. Now this one say in 4 steps, balance the following redox reaction in acidic solution. Now when you are balancing redox reaction, this is a fresh topic that I'm supposed to teach you from beginning. You guys are not going to learn oxidation reduction reaction. I think we learned it in chemistry at 300 level. You guys are not going to learn this. I don't know, for this level you might come across it in your CA or maybe practical exam, but I doubt anyway. But let's look at it together. Now, when you want to balance redox equation, we are taught this in secondary school, but I never understood it in secondary school anyway. Redox equation. How do you balance redox equation? Now, my dear student, there's something you need to know. Every redox equation has 2 equations in it. One is a reduction equation. The other one is an oxidation equation. Now, you should know that these 2 equations, they are not called equations, they are called half equation. So we have the reduction half equation, I will have the oxidation half equation. How do you determine which one is the reduction half equation and which is the oxidation half equation? It's very easy. First of all, let us take the first one. You discover the species here is SO32 minus, aqueous. Now, you give some space and then you write here SO42 minus, because SO32 minus was the one that gave rise to SO4 minus here. Now, we want to balance the atoms. If you look at it here, how many sulfur is here? 1 sulfur. How many sulfur? This thing I wrote like 8 here is sulfur, please. Something like this. How many sulfur is here? 1. How many sulfur is here? 1. So sulfur is balanced. How many oxygen is here? 3. How many oxygen here is 4. Now, my dear student, when you are balancing oxygen, you add water. When you want to balance oxygen in redox reaction, what do you add? Water. If you need 1 oxygen, you add 1 water, because 1 water contains 2 hydrogen atoms and 1 what? Oxygen atom. So if I need 1 oxygen, I add 1 water. If I need 3 oxygens, I add 3 water. If I need 4 oxygen, and I add what? 4 water molecule, and so on and so forth. So in this case, oxygen here is 4, oxygen here is 3. We need 1 more oxygen at this side to complete 4. So I am going to add 1 molecule of what? Water, H2O, liquid. Is that okay? Oxygen is now balanced. We have 4 oxygen here, 3 plus 1, 4. 4 oxygen here. Now, having gotten 4 oxygen, the next thing we need to get now, my dear student, is hydrogen, because when you added water, you've now introduced hydrogen into this equation. We must balance the hydrogen. If you want to balance hydrogen, you add proton. You add what, my dear student? Proton. Proton is H+. So we have 2 hydrogens here. So I am going to add 2 H+ here. This is aqueous. Is that understood? We've balanced hydrogen. So we have 2 hydrogens here, 2 hydrogen here, oxygen, oxygen, sulfur, sulfur. So oxygen is balanced, sulfur is balanced, hydrogen is balanced. The next thing we need to do now is to balance the ions, because all the atoms are balanced. Once all the atoms are balanced, the next thing is to balance the ions. So how do we do that? It's a very simple thing. Just calm down. Let's take it step by step. All right. So at the right-hand side, you are going to look. What ion do we have here? This is 2 negative. That is 2 negative ions here. At this side, we have 2 negative ion and 2 positive ion. Are you getting it? Because this 2 here is also affecting this positive charge here. So we have 2 negative, 2 positive. 2 negative, 2 positive here will cancel. And once it cancels, it gives us what? 0. So it is best written that at the right-hand side, we don't have any ion there because the 2 negative will cancel 2 positive. But at the left-hand side, we have how many ions? We have 2 ions here. Here, these 2 ions will cancel these 2 from here. So we don't have any ion there. So my dear student, you are going to add 2 electrons here. The 2 electrons you added here will now make the total ion here to be 2. Total ion here to be what? 2. So the ions are balanced. Now, most of you may not really understand it. Just copy. Is that okay? For this particular one, just copy. It's not a topic that you learned from scratch before, but I try as much as possible to explain it. But in case you don't understand, just do it. Just copy. Now, this is for the first one. Now, because the electrons was added at the product side, it means it's giving off. You say this is the oxidation half reaction. My dear student, what do you say? Oxidation what? Half reaction. You can put it there. Oxidation half cell reaction. Now the next one is the reduction. Let us look at this one. This is NnO4 negative. You give it some space and then you write this Nn2 positive. Now we need to balance. Like I told you, if you look at it very well, the manganese atom here is 1. Manganese atom here is 1. Oxygen here is 4. There is no oxygen at this side. To balance oxygen, we need to add water. We have 4 oxygens here, so we need to add 4 molecules of water at this side. Is that understood? Now that you've introduced 4 molecules of water, automatically you've introduced 8 atoms of hydrogen because 4 molecules of water contain 8 atoms of hydrogen. Is that okay? Because each molecule of water contains 2 hydrogens. So 4 molecules of water will contain 8 hydrogens. And to add hydrogen to this other side, because the hydrogen is at the right-hand side, we want to add it to the left-hand side. We need to add plus what? 8H positive. Now let us balance our ions. This is a negative ion here. This is positive, making it how many? 7 positive, because 1 negative, 8 positive. This 8 will affect this positive charge here. So 1 negative, 8 positive, 7 positives are here. Why if you come here, you only have what? 2 positive. So we must add electrons. We can only add electrons as ion. You add electrons that will neutralize this 7 positive to 2 positive. And how many electrons do we need to add here? No electrons are negatively charged. So we need to add like 5 electrons. Those 5 electrons are negatively charged. So they will cancel 5 positive from here. And then we'll be left with what? 2 positive from here. So my dear student, here will be plus 5 electrons. Now, because the electrons was added at the reactant side, we could say that the reaction is a reduction reaction. So this is the reduction half reaction. Reduction what? Half reaction. Now, my dear student, the next thing you are going to do now is we want to balance the electrons on both sides because the idea is in oxidation reduction reaction, the number of electrons that is lost must be equal to the number of electrons that is gained. Are you getting the idea now? So in this case, we have to balance the number of electrons on the oxidation half reaction and those on the reduction half reaction. So in a situation like this, what you need to do, how many electrons are here? 5. You use that 5 to multiply the top here. How many electrons are here? 2. So you use that 2 to multiply the one under. You exchange the number of electrons. Because 5 is here, use the 5 to multiply here. Because 2 is here, use the 2 to multiply what we have there. Use that 5 now to multiply everything we have down here. My dear student, what would that give to us? That will give us 5 SO3 2 minus aqueous plus 5H2O liquid, then going there 5SO4 minus 2 minus aqueous plus 5 times 2 will give us how many here? 10H plus aqueous plus 10E minus. Because these electrons here, they are 2 multiplied by 5 will give us what? 10E negative. Now these 2, you also use it to multiply everything you have here. So this will give us, my dear student, 2MnO form negative aqueous. Then we have plus 16HT aqueous. Then we have plus 2 times 5 will give us, my dear student, 10E negative. And then 2 times Mn2 plus will give us what? 2Mn2 plus aqueous plus 2 times 4H2O will give us what, my dear student? 8H2O liquid. Is that okay? Now, at this point in time, what are you now going to do? You are now going to cancel out the equations. You discover that we have 10E negative here. 10E negative here, they will cancel out. So long you have one at the left-hand side and the other one at the right-hand side, they can cancel out. So let us add the two equations, my dear student. What are you going to have? Now, look at water. How many water do you have here? 5H2O. How many water do you have here? 8H2O. Both of them, they are going to cancel out. So now, if you have 5 here, here you have 8. If you remove 5 from 8 here, how many will be remaining? Here we cancel. And here, because you have 5 here, here is how many? 8. You are subtracting them. Are you getting the idea now? Here is 5. Here is 8. If you remove 5 from 8, what are you going to have? Here will be remaining 3H2O. This one was used to cancel what we have here. Is there any other thing that can cancel? Yes, H plus. We have H plus here. We have at the other side. So long they are on different sides, they can actually cancel out. Now, H plus we have here is 16. H plus we have here is 10. So this 10 can go. And this 16, if you remove 10 from 16, how many will be here? 6 what? H plus. We are now going to add everything together. So my dear student, the final answer to this will be, now, add these two together. This will give us what? 5SO3, 2 minus aqueous. Please take note of the signs. Plus, you add this side too because you are adding both of them together. Here will give us 2MnO4 minus aqueous, all right, to give us this one. They already cancel now, Abi. So you come to this side, which will give us 5SO4, 2 negative aqueous, all right, and then what do we have? We have plus 2Mn2 plus aqueous. My picture, my video will be here. So let me put it down here. It's a continuation. It's a continuation. Just write it, continue your manual, but I just want to put it under here. So we have 2Mn2 plus, and then how many molecules of water do we have here? Plus 3 molecules of water. And this is the correct answer to this question. 5SO3 2 minus plus 2MnO4 minus. Okay, this 6, this thing, we did not write it. 6H plus, because I told you that when this one cancels, 6 will be remaining here. So you are supposed to have, let me reduce this one small so that we can have a little space. Plus what? 6H plus aqueous to give us this. Is that okay? 5SO for 2 minus plus 2Mn2 plus aqueous plus 3H2O. Is that okay? Now that is that for this particular question. Let us look at the next and the last question here. Now this is for acidic medium. Please take notes. They say balance in acidic medium. These are to balance in acidic medium. Now when we come to basic medium, we are still going to balance in the same way, but there will be a little change, like one more step. So to balance this one in a basic medium, first of all, let's take what we have here. The first one is Mn O4 negative. NnO4 negative aqueous. Now this one will give rise to NnO2 aqueous. How many oxygens do we have here? 2. How many do we have here? 4. So we need to add one more. We need to add 2 more oxygen. And I told you that to add oxygen, you add water. Because we are needing 2 oxygen, you add 2 molecules of water. To which side of the equation, my dear student? It's not to this side, it's to this side. So we have plus 2H2O. Is that okay? Now, the next thing now is hydrogens here, they are now 4. So you need to add 4 more hydrogens to this side, aqueous. All right. Now, can we now look at the charges? Plus 4H plus aqueous. Can we now look at the charges? The charge here is -1 plus this one is what? 3 plus. Here there's no charge at all. So we must neutralize this 3 plus here by adding 3 electrons. All right, this equation, because the electrons are added at the reactant side, you say this is the reduction half reaction. You can complete with reduction what? Half reaction. All right, the next one is this other one here. We have Cn negative aqueous, and then this one came to give us OCN negative aqueous. Now, this one has oxygen here, does not have oxygen here. So we need to add water here, plus a molecule of water. But there are 2 hydrogens here, so we need to add 2H plus here, aqueous. This is what? Liquid. Now, we need to balance the charges. This one has a charge of -1. This one here has a charge of +1. So to have a charge of -1, you need to neutralize these 2 positive here by adding 2 electrons. Because the electrons are added at the right-hand side, you say this is what? Oxidation half reaction. Now, the next thing now is to multiply by the number of electrons you have. Here, you have 2 electrons, so you multiply up by 2. While here, you have 3 electrons, so you multiply here by 3. Is that okay? Exactly. So, at the end of the day, you just multiply through, my dear student. This will give us 2MnO4 minus aqueous plus 8H plus aqueous plus 6E minus or 6E negative to give us 2MnO2, right? Because we are using the 2 to multiply through. All right, aqueous plus 2 times H2O. That will give us what? 4H2O. This is liquid. Is that okay? So that is the first step that you actually take in that for that particular one. Now the next one is to use this 3Cn to multiply through. Use the 3 to multiply Cn negative. That will give us what? Aqueous plus 3 times H2O will give us 3H2O. Going there, 3 times OCN minus will give us 3OCN negative aqueous plus 3 times 2H plus will give us 6H plus aqueous plus 3 times 2E minus will give us 6E negative. Now, my dear students, you cannot cancel. You see 6E negative here, 6E negative here, they can cancel. What other thing can cancel again? Water. Water can cancel. How many water do you have here? 3. Subtract it from the one you have here. How many you have here? 4. So we are left with 1 molecule of what? Water here. H plus can also cancel. You have 8H plus here. You have 6 here. So here, how many will be left? 2H plus. So total now, if you want to balance this equation, my dear student, is going to be, write everything you have here in a straight line. This will give us 2MnO4 negative aqueous plus we have 3Cn negative aqueous plus 2H plus aqueous to give us 2NnO2 aqueous plus then here we have 3OCn negative aqueous. I know this page, my screen will, let me put it this way, 3OCn negative aqueous plus nothing. I believe so. Plus nothing. Where is the water? Where's the water? We have one molecule of water left here. So we have plus, because I know water must be there at the end of the reaction. Plus H2O liquid. Is that okay? Now that you've gotten up to this point, but the reaction, they told you that it took place in what medium? In basic medium. Now, because the reaction took place in basic medium, you are going to write everything again. But then you are going to add OH to both sides of the equation. So I'm going to add OH because OH is a base now. Are you getting the idea now? OH will neutralize this H plus to give us more water, because when H plus reacts with OH negative, going to give us what? H2O. So the OH in the basic medium will neutralize this H plus here. So for each H plus, we need one OH. But here you have two H plus. So you are going to add two OH to both sides of the equation. So if we write everything again, 2NO, 4 negative, plus this aqueous, plus 3Cn negative, aqueous, plus 2H plus, aqueous, plus OH negative, aqueous. Told you that you add OH to both sides of the equation. Because you have 2H plus here, you have to add 2 OH negative. Why? Because the reaction is taking place in a basic medium, not an acidic medium. If it's acidic, at that point in time, you can end. At this point in time, you can end the whole reaction. But because it's taking place in basic medium, that H plus will be neutralized. So this will give us 2NnO2 aqueous plus 3OCn minus aqueous plus H2O liquid plus 2OH negative aqueous. Because the OH negative here must be the same with what we have here. So when these two combine, my dear student, they are going to give us water molecule. Is that okay? When these two things combine, they are going to give us water molecule. So this place here, it will now become 2H plus plus OH is now giving us 2H2O here. Here will now become 2H2O. But recall that we have one H2O here. So that one H2O, we cancel one H2O from here. So what are we left with here? One H2O. So the final reaction, my dear student, will be 2MnO4 negative aqueous plus 3Cn negative aqueous plus H2O aqueous. This will give us 2MnO2 aqueous plus 3, and put it down here, plus 3OCN negative aqueous plus what? 2OH negative aqueous. This NnO2, is it actually in the aqueous form that it was given or not? I believe that is the end of this particular practical. Is that okay? But let me confirm something from your manual. I was doubting this MnO2 because I know that MnO2 is supposed to be in the solid form, not aqueous. Are you getting it? So MnO2 is in the solid form, not aqueous. So please, this is a typographical error. So change MnO2. Anywhere you see MnO2 in this entire equation, put it in solid. The spirit of chemistry in me was telling me MnO2 cannot be in aqueous form. So I have to confirm this is solid, supposed to be solid. So wherever you see MnO2, please put solid. Is that okay? Anywhere you see MnO2, put what, my dear students? Solid. For, they worry this one. What was here? For something. You know what was there before now. Just change this one to solid. Sorry, not this one. No. This one is still remain aqueous. Any ion is in the aqueous form. Now this one is solid. All right. So that is that for this particular practical. We'll see you in the next one. Bye-bye.